the WDMA and the International Society for Strategic Marketing. So I promised you a little look under the hood, and I hope you can read the numbers. I'll describe what's going on. But what I've done is bring up our modeling tool, which is SPSS Shade. We have a special version of it, but it's not that special. Let me sort of explain what's going on here, and let's see what we can do. I talked last time about the dependent variable. So here is the dependent variable, best I can do it. What we've done is we've taken, a lot of people criticize Shade because, it gives you a p-value correlation, and the smaller the better, or it's actually the likelihood of non-correlation. It's a little hard to follow, but anyway, we won't get into that. But what we've done is we've taken the results from an actual mailing of about 500,000 pieces, and we've scored the ones that didn't respond and the ones that did respond. And the ones that did respond, we took the profitability, subtracting the cost of goods, the cost of order processing, and the cost of the mailing itself from the sales. And we're oversimplifying it, but let's just say that that's the case. Okay, so on this mailing, we had 209 people that were worth $1,814 on average profit. Okay, so they probably spent about double or triple that in their sales. So there's a few people that were worth a lot. Okay, and then in the same mailing, there were about 20,000 that were worth about $1,450 or so. Or I mean, $43 a piece. Okay, then there were also 751,000 that cost us 90 cents each. Okay, minus 90 cents. And those are the non-responders. And then there's some that are even worse that cost us $9 a piece. There were 7,600. Those are the people that bought and returned it all, and we charge them a second order processing charge. So we've got this spectrum of performance, and we bake that into Shade. Our system does that automatically, but it gives you an idea of the sort of the logarithmic performance of a mailing of, in this case, almost 800,000 pieces. Okay, so we'll close that, and the overall performance of the mailing was profit of $3.25, which is really good. I mean, it's really high. Okay, and so what I did was I let Shade just go and do its own thing. I didn't really look at any of the variables. I didn't care what it did. And the first one it picked up in correlating to that spread of performance was total margin. So the people that had previously spent a lot of money and made us a lot of money were worth $17.94. The people that had previously not spent a lot of money were worth 65 cents. These are all, these are all customers. We're not talking about prospects or anything like that. I want you to see the solidity of this. There's about 5 reasons why our AI works better than what you hear about in the marketing press. Okay? One reason is because we let the market tell us what's working. Okay, we send out 1 million pieces, 1 million catalogs, and we let it do what it does, but we apply about 400 variables to the history once it comes back. So we're letting the market tell us rather than just taking all the tweets and all the stuff and trying to see patterns that don't have a solid dependent variable. So the first thing is we let the market tell us. The second is we have a really good dependent variable. So our models tend to be, even with just random correlation, with just letting the machine do what it wants to do, they come up with solid stuff. The second level underneath this 343,000 is recency. And recency's here. Largest order 12 is actually a recency formula based on the previous 12 months. So everybody in here is well, not everybody. There's going to be some people that have a 0 if we click on that. The people over here haven't bought in the last 12 months, but the people over here have. Okay, so the first few levels are really solid, and it's partly because we work hard at getting the dependent variable right. Okay, but after that, it gets to be Nuttyville. Okay, so back here, we'll go to this recency, and this happens to be musical instruments. What we usually find is people who bought beginning guitars were terrible. They were just testing us out. They almost never come back again. The people who didn't buy beginning guitars were pretty good. Okay, that's a great example. But there's a lot of nuttiness in here that's just nutty. It's like over here is the proportion of male versus female. Higher male neighborhoods do better than lower male, but there's not much difference in a neighborhood. That's the joke of it all. I saw 80 here. Let's see how this one comes out. This is 3-digit zips and their percentage of population over 85 years old. Well, if there's a low, they do the worst. If there's a middle, they do the best. And if there's a high, they don't do quite as well. What does that tell you? I have no idea. Wait, it's over here. There's another one right here. For some reason, in this case, it did best if there was a lot of over 85 people. And this is part of the problem with AI in general. Okay, AI in general has, the correlations that the machine finds are there. But the question is, what do they mean? I don't know. Why is that? It's there twice, so we have a double shot. Okay, and that's part of the fun, because they will turn up. Now, because I've done this for now 25 years and thousands of models, I know not to trust these. What I would do in this spot here or in this spot here is I would say, well, what else is there? And if I hit the Control S, I find all kinds of more variables. Okay, it just goes on and on and on and on and on and on. And until I get down to about 5 pages of variables, that's where I run out of things that correlate, and it's just giving me alphabetical after that. So I would probably grab lines 24, which means how many line items did they buy? That would be a great one. Okay, and if we let that cook a little bit, it'll tell us what the profitability is. And I'm running too many things. And I'm running this remote, so it's not running as fast as I normally go. But I'll let you see what it does. This is what I do. So I go in there by hand and I poke it a little bit. I guide. I let the machine tell me the correlations, that set of 5 pages of stuff. And then I use my own experience to pick ones that are more solid. Okay? And it makes sense. If you bought multiple lines, multiple items, you're a little more of a solid buyer than if you just picked out one, like a beginning guitar, right? You're probably more of a musician than if you just picked one lone item. And also, we should remember there's 700. This thing's going through 700,000 records here, and there's 400 variables per record. So there's a little bit of stuff that it's going through. Not a lot. We can run them faster. The problem I have on most machines is they run so fast I can't figure out what's going on. And Lovely worked really well, showed me just what I want to see. I might split it just to get a little more spread. But you see out here, these are statistically invalid cells. And this is probably why Che didn't pick it, because they go down. So they start low, they go up high, then they come down. Now, it doesn't think about that this group only got 64 catalogs, so it wasn't statistically valid. So if I were going to do it, if I were going to split this reasonably, I'd go like this and like this. And then probably I'd go like this. Like that. Take them all. And what I end up with is $2, $4, $5.50. Perfectly solid. See, this is solid. What I just built is like absolutely it's gonna work in the real world. The 85 plus is not gonna work. I can tell you. It's just Nuttyville. Does it correlate with the actual results? Is it data driven? Is it data Is it data decision making? Absolutely. It fits all the criteria of AI. It's just nonsense. And that's the biggest problem with AI is spurious correlations. We get correlations across the board. All kinds of nutty variables come up. Here's climate. Let's see what it says about climate. It says that where it's warmer, we do better. Well, and I know that this actually does work, and it validates too. We'll get to validation in a second. So it validates because it grabs Southern California and Florida and Texas, and it's got a lot of money, and it's got a lot of musicians down there. Mobile homes also works. Percentage of mobile homes, probably because. Never mind. I got a lot of dumb stories about why these variables work and why they don't. But after a while, you see patterns in the variables over time. Anyway, so what's the next step? So the next step is knowing that some of these variables are nutty and some of them are not as nutty. What we do is we validate. And validation, and this happens to be a different client, but they all kind of look like that. What we do is we compare the model performance, high to low, with a second set of data. So we take that almost 800,000 pieces that we mailed, and we split it into 400,000 and 400,000. Still pretty valid, right? Pretty solid numbers. Pretty statistical certainty. In 400,000, we build a model, and then we take that same thing and aim it at the validation sample, and we find out if those variables still split in the same way, where we get a higher performance with the higher margin people and a lower performance with the lower margin people, that kind of thing. Okay? And so we get these graphs, and we also get a report, but the numbers are too small to see. So let's take this. This is running so slow. I've never had it run like this. Okay? Profit per piece, response per cell, average order. In this case, and in many cases, average order doesn't work very well. So here's the cumulative model. And you can see as we mail more and more pieces outside of our core, we get less and less profitable until it starts going negative. Okay, that's the model. And here's the validation. Pretty similar, pretty good. And if you've ever looked at the gains chart of models, you'll see this is an incredibly greater differential. But it's it's 80% about, which is about here. 80% of the model gives you almost 100% of your profit. What a surprise, eh? Okay, so that's the validation. And I want to just take a second to say. So we have first we let the marketplace tell us what works and what doesn't with our offer and our mailing list. Second, we build a model to see the variables that matter. We take control of that machine a little bit. Third, we do a validation. Fourth, okay, so we got a model and a validation. Then guess what else we do? We look at it in the real world. And this is a totally different client, but we'll just show you what it does. And one of the problems with this client is that they have a large business-to-business component, which sometimes we just take out because they're sort of easy to spot, and they already are servicing them well. But we line up. Let's see if we line up the validation and the actual results, and you can see they jump along really nicely together. Here's the average order. I mean, you can see they're going right together. It's so beautiful. I mean, it's really beautiful. This thing is just, it's amazing. And so not only do we do the model and the validation, right? But we also get actual results based on those variables. Not based on an algorithm where we can't tell what's going on, but based on a variable by variable performance, which gives us insight into the anomalies. And we can spot things that we never expected to work. And oftentimes that turns into new businesses, and that's how we get explosive growth. And that's just a little picture of what it means to do predictive modeling. Let's see if I've got any other good graphs here. So I'm going to turn off the machine. Look at that. Here's actual mailing results. That's what it gets you. It gets you so you know how much to mail and you know your ROI. And that's what it's all about. I'm John Miglosh for the WDMA and the International Society for Strategic Marketing. Have a great day.